In 1903, the Wright brothers used American ingenuity to achieve the first powered, controlled, and sustained flight at Kittiawah, North Carolina. But over the next decade, European nations invested in aviation research, leaving the United States behind by the time of the First World War. To advance U.S. flight research, a committee of government, military, and industry leaders was formed in 1915. It was called the National Advisory Committee for Aeronautics, the NACA. It contributed to some of the most important advancements in the history of flight. And its people, its laboratories, and legacy became the basis for NASA at the dawn of the space age. Founded in 1917, Langley Memorial Aeronautical Laboratory was the first established NACA facility. With only one wind tunnel, 2 hangars, and an initial staff of 11 people, flight research in the early years was humble. By the time the first wind tunnel began operations, the design was already obsolete. But the next lab influenced the shape of wings for generations to come. The variable density tunnel put Langley at the forefront of aeronautical research, becoming the prototype for subsequent pressurized wind tunnels. Another breakthrough was the development of protective engine covers. They reduced drag while cooling the engine, an unexpected achievement that defied conventional wisdom. This accomplishment was honored in 1929 with the prestigious Collier Trophy. Langley engineers relentlessly designed cutting-edge test facilities and devised practical solutions for problems encountered with flight. By 1939, there was no more space to build, so expansion moved west. The core group of researchers at new labs across the country came from Langley. At the end of World War II, the NACA initiated research into rockets and faster-than-sound flight. Human spaceflight in the United States began at Langley with the Space Task Group, which managed Project Mercury. As the first NASA research center, Langley continues to innovate in aeronautics, space technology, and science, more than 100 years after its founding. Before NASA and before Silicon Valley, American aeronautics needed space to grow. The onset of World War II made it clear that if the U.S. wanted a competitive advantage in aeronautics research, it had to expand its footprint. In 1939, the National Advisory Committee for Aeronautics, the NACA, chose Moffett Field in California as the new location for this effort. Built next door to a naval airfield, the Ames Aeronautical Laboratory had the resources and the space to develop world-class test and research facilities. That included the world's largest wind tunnel, which opened in 1944. Wind tunnels at Ames operated around the clock. They provided the data needed to devise quick and practical solutions to potentially fatal problems. Testing at Ames of the iconic P-51 Mustang led to modifications that fixed unwanted vibrations in flight. The formation of ice on wings was an even more serious concern. Ames engineers developed a system that redirected hot air from the engine to the wings, saving countless lives as a result. This work earned the Collier Trophy, the nation's highest award in aviation. The supersonic age and the Cold War put high-speed aeronautics and missile research at the forefront of Ames activities. Test pilots flew the most unique aircraft ever built. Researchers continued to build innovative wind tunnels. and revolutionary insights from flight research produced breakthroughs that made it possible to safely return humans from space. To get off the ground, you need an engine. 20 years before rockets carried the first humans out of our atmosphere, the NACA built a laboratory dedicated to aircraft propulsion. Construction began in 1941 in Cleveland and became what we know today as NASA's Glenn Research Center. The focus on piston engine performance during the war evolved into testing some of the nation's first jet engines, improving turbojet and ramjet designs in the 1940s and 50s. Researchers at the lab advanced aviation safety, expanded the NACA's award-winning icing research, and developed crash fire prevention and passenger restraints. In the atomic age, it was in Ohio that the NACA investigated nuclear propulsion systems for aircraft and rockets. Beginning in 1958, the lab applied its aeronautics expertise to space. High-energy propellant research led to NASA using liquid hydrogen in most upper-stage rockets and the space shuttle. Investigations continued into cryogenic propellant handling and microgravity research. In 1962, the center became responsible for the Centaur rocket program. It sent the Surveyor spacecraft to the Moon, launched probes to the outer planets, and placed scores of satellites into orbit. Above the deserts of Southern California in 1947, the American rocket-powered X-1 experimental aircraft broke the sound barrier. It signaled the future of aviation and opened a new chapter in the history of flight. An important part of the X-1 team came from the NACA's Langley Aeronautical Laboratory in Virginia. This group of research engineers and test pilots founded the NACA's High-Speed Flight Research Station west of the Mojave Desert, which became NASA's Armstrong Flight Research Center. Armstrong has been home to the design and testing of experimental aircraft since the sound barrier was broken. Whether taking the X-15 to the edge of space, or testing the concepts that allowed the space shuttle to land back on Earth, going to space and returning has always required flight testing in the atmosphere. The NACA's legacy lives on today at NASA's research centers. After more than 100 years since its establishment in 1915, the NACA's creativity and pursuit of the fundamental challenges of flight in the skies above and the space beyond remind us that the first A in NASA is aeronautics.